So here's the thing on how to identify significant figures. So in our case, I'll just write for shorthand significant figures. I just use SF to denote significant figures. So it is considered that all non-zero numbers are significant. So non-zero means 1, 2, 3, 4, 5, 6, 7, 8, 9. So all of these non-zeros are significant. So if you have that number, if you can see that these numbers in your measurement, again, if we're talking about physics, usually numbers represent a measurement or quantity. And zeros are kind of tricky, so it's kind of trivial. So you have to take note. So there are four types of zeros, okay? So one is significant zero. So not all zeros are insignificant. And this particular zero are actually we call sandwich zeros. So let's say 2, 0, 1, okay? So it is sandwiched between two non-zero numbers. So if it is sandwiched with two non-zero numbers, you're gonna count the zero in between as significant, okay? So therefore, this is significant. This can be considered a significant figure and as well as the last one. So therefore, if you're gonna count the number of significant figures or significant digits, that is 3 significant figure, okay? So let's say, for example, if you have another one, which is, let's say 2001, well, this particular number here has 4 significant figures because the zeros are sandwiched, okay? And after decimal, after number, trailing decimal. So second situation is that if you have after decimal, so zeros after decimal and 0 after a number. So these are called trailing decimal. So in this particular case, these are considered. So let's say I'm just gonna use an example here: 0.08. Okay. So in this particular case, the zeros in front are insignificant, but the number 8 there is significant. So the only significant digit here is 8. So this is the significant figure. So essentially, this is one excuse me, significant figure. If we have another example, if you have 0.080, maybe some of you will think that why the trouble of placing the 0 after 8? Well, the thing there, the zeros in front are insignificant, but the zeros after the non-zero number are called significant. So this would be significant figures. So therefore, in this particular case, you have 2 significant figures. Okay. So again, the 0 in front here are insignificant, but the 0 after a non-zero number is significant. Okay. So other is the insignificant zeros. So these are the leading zeros. Let's say, for example, you have 0.00002. Well, essentially, I don't have any decimal there. So actually, you only have, this is just equivalent to 2, right? So this is just one significant figure, okay? And before decimal and after the number or trailing zeros, I think this is same thing as before. But let's say, for example, for number 200, the zeros after, I don't have any decimal point after the zeros here. So actually, this is just has 1 significant figures. So the significant digit is just the number 2. So the zeros here are insignificant. This is the significant figure. So if you want to express this one as the zeros there are significant, sometimes you try to write it in scientific notation, like 200. If you want to specify the correct number of significant digits, let's say, for example, I want to express it as 3 significant figures because, for example, it can read up to, it's a certain measurement. So how would I do that? Well, is it not that sometimes in some books you would see that even though the value is just 500 or 200 in this case, they will try to write it as 2.00 times 10 to the power of 2. Because when you try to do that, this becomes 3 significant figures. Or sometimes you would see 200 and then they will try to place a decimal after 0. That is just to indicate that I want to indicate that I have 3 significant figures.